Welcome to day 10. So this is our first of 2 review days. Keep in mind you have homework tonight. Packet page 62 to 63 is not within the review pages. Okay, but it will be some additional proof review practice for similar triangles. So 62 to 63 is your homework. So going over our homework from last class. So if we set up our 3 triangles, so that's the purple one, which we knew 3 and 1 and y initially. That green one, which we don't have anything initially, we have y, x, and z. And then our blue one is the big one, which initially we have 3z and x plus 1. Well, in the purple triangle, we had 2 of the 3 sides, so we could just do Pythagorean theorem and get either square root of 8 or 2 square root of 2. So once you have that 2 square root of 2, you could label that all the places that you had y. Well, now we can use the purple triangle and the green triangle to find x. So 1 over 2 square root of 2 is equal to 2 square root of 2 over the x. Cross multiply and solve, you get x is 8. So now we know this is 8. 8 plus 1 is 9. So then I use the blue triangle to do Pythagorean theorem to find z. And you eventually get square root of 72, that when you do your menu number factor, that gave you 2, 2, 2, 3, 3, pair of 2s, pair of 1, 2, 1, 3 out front. So you get 6 square root of 2. In B, that was our blue triangle. That's our green triangle. And we'll maybe do red for the big triangle. So initially I used the blue and the green. I did the 5 over the y is equal to y over 11. Cross multiply and solve, you get square root of 55 for y. Once you had that square root of 55, then I used the blue triangle to use Pythagorean theorem. You end up getting square root of 80, or in other words, 4 square root of 5 for x. Moving on to 2, I use the side splitter theorem here. So x over 2 is equal to 13 minus x over 3. Cross multiply and solve, you get either 26/5 or 5.2. You also could have used similar triangles and used that the sides were proportional. We had that triangle and then this triangle. Well, in the blue triangle, that would be 6. When you add 13 minus x and x together, you get 13. So you could do x from the purple triangle over 13 from the blue triangle is equal to 2 from the purple triangle over 6. Oh, I misadded there. Sorry. 2 plus 3 is 5, not 6. So over 5 in the blue triangle, so you'd get 5x equals 26. And notice that would lead to the same thing. In the next ones, just find the ones that match up. So A to D should match with B to E. Then we should have EH, DG, and BG, and BE for the last one. For this one here, 1 and 2 match up. So I use this 1 over that 2 equals 2 over x. Cross multiply, you get 4. In the next one, x over 2x minus 8 is equal to x over x plus 8. You've got to cross multiply. The x has to distribute through, and on the right there you had to FOIL out. We want to get everything on one side so it's equal to 0, and we like a positive x squared, so I subtract everything over with the 2x squared, and you get x squared minus 6x minus 40. That factors into x plus 4 and x minus 10. When you set those equal to 0, you get 10 and negative 4. However, one of our sides is x, and we can't have negative 4 for a length, so we reject the x is negative 4 and just have x equals 10. So for today's portion of the review, we are going to focus on the proofs and the constructions. So our first one we're actually going to do is on the bottom of page 66. We'll do all the other algebraic type ones on day 11. So here's our first proof, number 13, which is on page 66. And we'll start out by getting down our statements and reasons and givens. So based on our proof, we've got a ratio of, or a proportion of sides, so that should lead us to know we want similar triangle proof. In a similar triangle proof, we always try to get two sets of angles congruent. So that's our plan. Get two sets of angles congruent, then do our similar triangles, and then do our extra steps. There's only two triangles in our picture, so we don't have to figure out which ones they are. We got the small one and the big one. We'll notice when we trace the small one and trace the big one, they share angle A. So we can do that reflexive right away. So we'll do angle A congruent to angle A by the reflexive property. Based on our givens, we then want to do perpendicular lines imply right angles. We've got DC perpendicular to AC, so that would give us that angle C is one of our right angles. So angle C and then BE is perpendicular to AD. Well, we want the one that's going to be in the red triangle, so let's maybe number that one 1. So angle C and angle 1 are right. Well, now we want to automatically do right angles implies congruent angles. We're pointing at congruent angles, so we'll say that that angle C is congruent to angle 1. And we'll want to mark it in our picture with our box. Well, now we got two sets of angles. We are ready to prove these triangles similar. So we'll use our angle-angle similarity postulate. For the triangles, we'll go AEB for the first one is similar, so just the one squiggly, to triangle. We started with A, which was the reflexive, so that has to match with A in the other one. Then we went to E, which was our right angle, so that must match with C in the big one, and then we'll finish with D. After we do triangles similar, we can say the sides are proportional. So we've got similar triangles implies proportional sides. And that's our proof step that we want. We want our sides written as a proportion, so we'll write that and then we'll be done. So whether you see your proof statement as triangle similar, or if you see these proportions, or as we'll see on the next one, if you see the sides multiplying, all those should lead you to think that we want a similar triangle proof. So get two sets of angles congruent. Moving over to the next one on page 67, go ahead, get your statements, reasons, and givens down. So in this one, we want to prove our proof statement. We have that we're multiplying segments. So that comes from our cross multiplying. The product of the means equals product of the extremes. So that should lead us to know, okay, we want similar triangles. We're going to try and get two angles congruent. Well, we've got lots of triangles in this picture here. I count at least 5 different triangles. So go through your segments until you find a segment that's only in one triangle. So let's start with RW. RW is actually only in one triangle. It is only in RWT. So RWT is one triangle that we're going to work with. So let's look in here. RW is a side in RWT, and there should be one more side that's in RWT. TW would be the other one. That means SV and RV should be the sides in the other triangle. So if we're doing SV and RV, we would want that triangle there. And then we said RWT was the other triangle. So these are the two triangles we are trying to get similar. And that's you'll see on the homework tonight, it's going to be the same picture all 3 times, but there's going to be different sets of triangles we want to get similar. So you'll have to do this process of finding a side that's only in one triangle to identify the first triangle, and then whatever the 2 leftover sides are, that'll tell you what the second triangle is. So let's go with our givens. We've got an angle bisector, so we'll do angle bisector implies 2 congruent angles. TRS is what is being bisected. So the middle letters are, so that's where the bisecting is happening. So let's call those 1 and 2, and we'll say angle 1 congruent to angle 2 and mark it up in our picture. So we've got one set of angles, we still need another. Well, we got to think, why are they possibly giving us TW congruent to TV? Well, TW and TV are sides within triangle TVW. If you've got 2 congruent sides, you can say it's isosceles. So let's do 2 congruent sides implies isosceles triangle. And our statement will be triangle TVW is isosceles. Well, then the next logical thing would be to do isosceles triangle implies 2 congruent base angles. And the base angles are the ones that are across from the congruent sides. So let's go ahead, we'll label those maybe 3 and 4. And we'll have for our statement that angle 3 is congruent to angle 4. What I called angle 4, you could have labeled easily as angle W also if you wanted. Well, that's another set of congruent angles, but angle 4 is in our green triangle, but angle 3 is not in the blue triangle. So we're not done yet. But something we have there, we've got some crisscrossing lines right here. So we can do vertical angles. So let's throw that as angle 5. So we can do vertical angles implies congruent angles. So that will give us angle 3 congruent to angle 5. Well, notice now 3 got marked up in 2 different ways. 4 is congruent to 3, 5 is congruent to 3, so we should now be able to say that angle 4 is congruent to angle 5, and that's by the transitive property. So 1 and 2 are congruent, 4 and 5 are congruent, so now we have our 2 sets of angles, so we can do our finishing steps now for a similar triangle proof. So first we'll do our angle-angle similarity postulate. and we'll say our triangles are similar. I'm going to call the first one RVS. It's similar to triangle. R was the angle 2, that should match with angle 1, so that's also R in the other one. V was my angle 5, which that was congruent to angle 4, so that should go W. And then the last letter is T, so RWT. So like we did in the last proof, next we'll do our similar triangles. Implies proportional sides. Now we've got to set up the proportion this time. We need the ones multiplying each other to be diagonal from each other. So I'm going to put RW here, and SV has to be diagonal from it. And then RV and TW can be in the other two spots because they'll be diagonal from one another. And then our last reason will be what we want to, or our last statement will be what we want to prove. We've just got RW times SV is equal to RV times TW. And our reason is our product of the means is equal to the product of extremes. So that's it for the proof ones. We'll see some of those on the homework assignment. We're now going to look at some construction ones. So we've got triangle ABC, and one angle is already copied for us. We've got C prime there, and we want a scale factor that is half the size. So what we need to do is we need to find the midpoints of both CA and CB, so that we'll then be able to measure half of the length of each of them. And we'll do that by doing our segment bisector construction. So in your segment bisector construction, put your point on one end. We're going to bisect CB right now. Make sure you're open over halfway. Swoop it up and swoop it down. And then we'll reverse it. Put your point over on B. Swoop it up and swoop it down. And then with your straight edge, connect those intersection points. And that tells us where our midpoint is on that one. So then we'll do the same idea for AC. Oops. Same idea for AC. Put your point on A. And make sure you're over halfway. Swoop it up and swoop it down. And reverse it. Where those cross. With your straight edge draw. And that's now our midpoint on AC. So we got our two midpoints. So now with your straight edge, we want to extend these lines from C prime. And what we'll do is with our compass, we'll measure from C to each of our midpoints and then label them. So I'm going to put my point on C, and I'll move my pencil to the midpoint. And then over here, I'll pick one of the lines to mark that off on. So that point that I just marked, I got it from the CA, so that's going to be A prime. And then I'll do a similar idea. I'll measure from C to B, it's midpoint. And I'll go over to C prime. And I'll mark off on the other one where that is. And that's my B prime. And then just connect them with your straight edge. So next one over on 16, we'd want to construct this so it's 3 times the size. Now you're going to need some space for this. So I'm going to start out and I'm going to put point, or I should say, so start out, draw a line segment and draw it pretty close down to question 17. And I would say maybe start it kind of above the word method. And just draw yourself a long line segment for right now. We're going to make this point here be point E prime. So the first thing we have to do is we have to copy our angle E. So with our compass, we're going to put our point on E and make any convenient arc. So make any convenient arc. And then keeping your compass the same, come down and do that same arc from E prime. And make it big enough because we don't know where it's going to intersect at this point. Once you've got that, come and set your compass so it's the distance of your intersections in this original one. And then bring that down and put your point on the intersection we know and make an arc to see where they intersect. And then what we want to do is we want to use our straight edge to go from E prime, go straight through that intersection, and go out a ways. Because we're going to triple the length of these, so we're probably going to need pretty long. So once you've done that, we want to measure the length from E to F. And then because we want a scale factor of 3, we're going to mark off 3 of those down here. So there's 1, there's 2, and there's 3. So that last spot is F prime. So now we've got to go up, and we'll set our compass to E to D. And then bring that down to our segment here, and we'll mark that off 3 times. 1, 2, and 3. So that is D prime. And then to finish it off, hopefully your straight edge is long enough, we've got to connect from D prime down to F prime. And that figure on your paper should be 3 times, the length should be 3 times the lengths of the original. And now if yours, like I shifted my picture just so I could do it on the smartboard and my compass would fit. If yours might overlap the original picture a bit, and that's okay. All right, going down to 17. So this is saying we want to do a dilation centered at O, and we want to do it by a scale factor of 2. So start out, take your straight edge. We're going to go from O and extend a line a ways through each of the key points there. So this end point we want to extend through, this point, and this point. So 4 times with your straight edge, just extend a ways through each of those. And we'll take out our compass. Measure from O to your point. We want 2 of them, so we need 1 more. So we'll have that point as our next point. Go back to O. Measure off where the point is. Measure off another one. Now we have 2 of them. Point on O. Pencil on the other point we wanted. Move your compass, mark off another. So now it's showing the scale factor of 2. And then do the last one, same idea. And then with your straight edge, connect them in the same manner that the original was connected. So this one connects to there, that one connects to there, and that one connects to there. And we've now dilated our original figure with a scale factor of 2 centered at O. And our last one for this video will be 18. We want to find the center of dilation. So we'll be just using our straight edge here. So start at G and use your straight edge and connect it through G prime a ways. We'll go H through H prime. And that should be it, but go I through I prime just to confirm that it ends up at the same spot. And so this would be our center of dilation. Sometimes the question says to label it with a letter. This one did not ask us to do that, so we just got to put a dot there. So that's our center of dilation. This one, based on our primes being closer, it was probably something like a scale factor of 1/2 because our image was actually closer to the center of dilation than the pre-image. All right, that's it for this video. Remember, you got the homework pages to do tonight. Should be some similar triangle proofs, and have a great rest of your day.